In this video, we're going to talk about exponential and logarithmic equations. The first kind of equation that we're going to talk about is exponential. And the first ones are the most simple ones. However, they do take some skill. So for instance, the most easy ones are ones that have the same base. So one of the skills we need to have is learn to rewrite an equation in a different base or a smaller base. So for instance, 64 to the x, well, 64 can be written as 4 to the fourth, and just keep the x. Similarly, 1 over 49. If I'm going to use that as base 7, I know that 7 squared is 49, and for a fraction, I can make that negative. So 1 over 49 to the x can be written as 7 to the negative 2x. Then things can start to get a little bit more difficult when I have the square root of 2 to the x plus 2, if I needed to write that as base 2. Well, recall that the square root of a number is the same as an exponent of 1/2. So I can rewrite that as 2 to the 1/2 times x plus 7, with the 1/2 and the x plus 7 all in the exponent. So then all I have to do is just simplify the exponent. I distributed in the 1/2. So that's 2 to the 1/2 x plus 7/2. So let's see what this would look like in an equation. So here's one problem. I have 25 to the 3x minus 1 equals 125. Well, I can see that I can write 25 as 5 to the second power. And I can write 125 as 5 to the third power. So when I did that, notice that the 3x minus 1 is still there, but the 2 is in front. So because they have like bases, if the bases are equal, the exponents must be equal then too. So I can just drop the 5's. So I get 2 times 3x minus 1 equals 3, and it's a straightforward linear equation. Okay, distribute in the 2. Okay, I get 6x minus 2 equals 3. Add 2 to both sides. I get 6x equals 5, and then divide both sides by 6. Okay, the 6's cancel, and I get x is equal to 5 over 6. These are the most simple equations, even though they have many steps. So let's see one that's a little bit more difficult. Okay, and that's one where we do not have like bases. So if you don't have like bases, okay, we can use logarithms. Now, recall to convert an expression into log form. Okay, all I do is the base of the power becomes the base of the logarithm. The exponent goes to the right-hand side of the equal sign, and what it equals goes to the left-hand side of the equal sign inside the logarithm. So here's an example. I have 6 times 4 to the k plus 4 equals 30. Now, you have to get the power by itself. So divide both sides by 6. Okay, the 6's over here cancel. 30 divided by 6 is 5. Okay, now I cannot get the same base for 4 and 5. So that's when it's time to use a logarithm. Okay, you only use a log to get the variable out of the exponent. So I bring it straight down. The 4 becomes the base, the 5 goes inside the log, the exponent goes to what it equals. So now I just solve it like I would a typical equation. I'm just going to subtract 4 from both sides. Now, remember, you cannot touch what's inside a log. Okay, so log 4 base 5 minus 4 just becomes log of 5 base 4 minus 4 equals k. So the 5 is inside the logarithm. The minus 4 is not, so we cannot touch it. Okay? Now, then there's the little known number that's called e. Now, if you have questions about e, you're more than welcome to ask me in class. Okay? E is what they call the base of the natural logarithm. And I'll talk about that in just a moment and how it looks a little bit different. So e is not a variable, it's a number. V as in Victor is our variable in this case. So before I can do anything, I have to get the thing that has the exponent by itself. So I'm going to subtract 3 from both sides. Okay, so minus 3 from both sides. That gets me 5 times e to the negative 2v minus 10 equals 30. Now I'm going to divide both sides by 5. Okay, 30 divided by 5 is 6. Now I have my power by itself, and it equals a number. So now I can convert this into log form. Now, log base e, has its own special notation. Log base e is also written as ln, meaning natural log. Okay, and it's understood that the base of this is e. So that's what I do here. So I go straight down. Okay, the exponent goes to the right-hand side. What it equals goes inside the logarithm. And now I'm going to solve it just like I did the last time. Okay, but I'm not going to touch this natural log of 6. I'm going to add 10 to both sides. Now remember, you cannot add the 6 and the 10. The 6 is inside the logarithm. Okay, so I get natural log of 6 plus 10 equals negative 2v. So now I'm going to divide everything by negative 2. Now, if you choose, you can simplify this. Okay, you can divide both of these parts by negative 2 if you so wish. Okay, but remember, you cannot touch that 6. It's inside the log. So if you wish, you can go to this step and say negative natural log of 6 divided by 2 minus 5, because that's what you get with 10 divided by negative 2, equals v. Okay, we'll see more of the natural log in class as the days go by. So now, that's how we handle it when we're given an exponential equation and we cannot solve it by using like bases. So now, the second type of equation that we're going to look at is when the variable is inside a logarithm. The first kind is the simplest kind, of course. Okay? When you have two logs with the same base. Okay? Just like before, if an exponential expression, the bases of the exponents are the same, that means the exponents are the same. Same thing here. If the bases of the logs are the same, that means what's inside the logs is equal. So I could just drop the log base 8 and write 2x plus 9 equals 6x minus 7. And now I just solve that with any number of steps. I'm choosing to get the variables on the left-hand side, so I'm going to move this 9 to the other side. So I'm going to subtract 9 from both sides. Okay? So I get 2x equals 6x minus 16. So now I'm going to move the 6x to the other side. So I'm going to subtract 6x. Okay, I had a little bit of a boo-boo here. Don't worry about that. So 2 minus 6 is negative 4. 6 minus 6 cancels out, and I'm left with negative 4x equals negative 16. So divide both sides by negative 4. Okay, and I get x equals 4. Now, when it comes to logarithms, you really should check to make sure that when you plug this number in, that you do not get a negative number. You cannot take the log of a negative number. Okay? And I warn you only because this expression over here has a minus sign. Okay, whenever you have a minus sign, you should plug it back in to double check. So, 6 times 4 minus 7. Well, 6 times 4 is 24 minus 7. And 24 minus 7 is 17. I don't know what the log base 8 of 17 is, but I know that's not negative, so I can do it. This answer exists. Okay, so that's the simplest log equation. What happens if we have ones that are a little bit more complicated? Well, I'm ready for that. So here are a couple examples. Okay, first of all, I'll remind you that to convert from log form to exponential form, okay, the base of the logarithm becomes the base of the exponent. What's inside the log becomes what it equals, and the original statement, what it equals, becomes your exponent. We're going to use that in just a moment. So here's my equation. 3 plus log base 8 of 10x equals 6. So I'm going to get the log by itself. Okay? So I'm going to subtract 3 from both sides. Now, log base 8 of 10x equals 3. I'm stuck. There's nothing more I can do. All right? So when there's nothing else over here to move, it's time to switch. So the 8 is going to become big. The 3 becomes my exponent. The 10x becomes what it equals. All right? So 8 to the third. I used my calculator. That's 512. That equals 10x. So divide both sides by 10. And you can simplify 512 over 10 to 256 over 5. That problem wasn't so bad. The other variety that you could see might be one that includes the natural log. And other than remembering that it has base e, it's not that big of an issue. So here's my problem. 3 times the natural log of 5x plus 2 equals 15. So I have to get the natural log by itself. So I'm going to divide both sides by 3. Okay? These 3's cancel. 15 divided by 3 is 5. Now the log is by itself and it equals a number. So now I'm going to take it out of log form. But I have to remember that this base is e. So I'm going to have base e. What it equals becomes my exponent. What's in the log moves to the right-hand side. And now I'm just going to solve. Okay, however, e behaves like a variable in this case, meaning we can't add any numbers to it. All right, but we're going to solve for x. So I'm going to subtract 2 from both sides. Okay, so that gives me e to the 5th minus 2 equals 5x. So now I'm just going to divide everything by 5. Okay, so these 5's cancel. So I get x equals e to the 5th minus 2 over 5. Okay, that's a good variety of log and exponential equations. That should prepare us for what we talk about tomorrow. Have a good day.